Hello intellectuals, I am SK Thakur and you are watching this video in Digital Maths Academy. Let's continue some more identities. Number 6. Here also we are going to select left hand side only. So left hand side equals to under root sec squared a plus cosec squared a. So first of all, we are going to change sec squared a and cosec squared a into sin and cos. So sec squared equals to 1 by cos squared a and that of cosec squared equals to 1 by sin squared a. Yes, we know its formula very easily. Now we are going to take LCM cos square a and sin square a. LCM of cos square a and sin square equals to cos square a into sin square a. After that here, for the first fraction we can write here sin square a, and then for the second we can write here cos square a. After that you can see sin square a plus cos square equals to 1, and down of that we have here cos square a dot sin square a, isn't it? Now we can write here under root 1 by cos square is sec square a and 1 by sin square equals to cosec square a. Of course we can write. Now here we have square root, so we can write here sec square a and cos square a as sec a dot cosec a, and its whole square also we can write. Then whole square and under root both will cancel, and finally we have sec a dot cosec a, and it's our right hand side, so we can write here equals to right hand side and then proved. Number 7. Let's choose left hand side here also. So left hand side equals to, we have here a cos a plus b sin a and its whole square. Similarly we have here a sin a minus b cos a and its also whole square. So we are going to apply a plus b whole square formula, that is a cos a its whole square, a square plus 2ab, right? So 2 dot a cos a, okay, a cos a, then we have here dot b sin a, and plus b square means there is a, we can write here b sin a and its whole square, right? Likewise for another term we can write a sin a, so at the place of a we have here a sin a whole square minus 2ab, right? So minus 2 dot a sin a dot b cos a and plus b cos a, and we can write here whole square. After that we know a cos a whole square means you can write here a squared cos square a, and for this part 2ab you can write here 2ab, and you can write here sin a dot cos a, and here you can write here b squared sin square a. Likewise, for this term you can write here, for this term, I am going to show you, for this term you can write here a squared sin square a, and for this term we can write here minus 2 sin a dot, yes, we can again write it as, we can write it as minus 2ab sin a dot cos a, right? And plus we can write here b squared cos square a. So now we can see 2ab sin dot cos a, and here also 2ab sin dot cos a we can cut, and finally we can write here what we have here. So a squared cos square a, right? And here also we have a squared sin square a, so we can write here a squared sin square a also we can write. Likewise we have here b squared sin square a, remaining parts we are going to write here, and plus b squared cos square a also we have. Now we are going to take common here, a square is common, so then you can write here cos square a plus sin square a, and here b square is common, so we can write sin square a plus cos square a, and after that a square into 1 we can write plus b square into 1, because sin square plus cos square equals to 1, and finally we have here a square plus b square, that's the right hand side, so we can add at last proved. Number 8. Here we have left hand side equals to 1 plus tan a its whole square, plus we can write here 1 minus tan a its whole square. So I am going to apply formula a plus b whole square, that is 1 square plus 2 dot 1 dot tan a plus tan a whole square, right? So we can write here tan a whole square. Likewise, for another part, we can write here 1 square minus 2 dot 1 dot 10a plus 10a, we can write here whole square, because a plus b whole square or a minus b whole square, we know the formula. So 1 square is 1 here, plus you can write here 2 into 1 is 2, then you can write here 10a, and 10a whole square means 10 square a, right? Plus also you can write here 1 minus 2 10a, and here also you can write here 10 square a. After that 2 10a and plus 2 10a minus 2 10 will cancel, and remaining we have here 1 plus 1 is 2, and 10 square a plus 10 square equals to 2 10 square a, isn't it? So we can take 2 common, and we have here 1 plus 10 square a, and finally we have here 1 plus 10 square equals to 2 sec square a, right? So we know that sec square a minus 10 square a equals to 1. So from this relation 1 plus 10 square is equal to sec square a, and 2 sec square a is our right hand side, so we can write here equals to right hand side, and then finally you can write here proved. Number 9, we have here left hand side equals to 1 by cos sec theta minus cot theta. So at the place of 1 we can write cosec square theta minus cot square theta, right? Because cosec square theta minus cot square theta equals to 1. At the denominator we write cosec theta minus cot theta as it is. Now at the numerator we are going to apply a square minus b square formula, according to which we can write here cosec theta plus cot theta, that is a plus b, and a minus b, that is cosec theta minus cot theta, right? So we are going to apply the formula, we apply, and at the denominator we have cosec theta minus cot theta. After that we can cut one factor up and down, cosec theta minus cot theta, and finally we have here cosec theta plus cot square theta. Cosec theta plus cot theta, which is our right hand side, so we can write here equals right hand side, and then you can write here proved. Number 10, here also we are going to select left hand side, and left hand side equals to 1 by 1 minus cos alpha minus 1 by 1 plus cos alpha, right? So now we are going to take LCM. LCM is 1 minus cos alpha and 1 plus cos alpha. Yes, it's the LCM. So we can see here there is we will have here 1 plus cos alpha and minus, so after minus we can write inside the bracket 1 minus cos alpha. When you open the bracket we have here 1 plus cos alpha minus 1 and minus plus cos alpha. Then we have here a plus b, a minus b, so we can write here 1 square minus cos square alpha, because a plus b, a minus b equals to a square minus b square. So here plus 1 minus 1, yes, we can cut, and finally we have here cos alpha dot cos alpha plus cos alpha equals to 2 cos alpha, and here we can write here 1 minus cos square alpha. After that at the numerator we write as it is, there is a 2 cos alpha, and at the denominator we have here sin square alpha, because 1 minus cos square alpha equals to sin square alpha. Now we can write here 2 cos alpha divided by sin alpha dot sin alpha, isn't it? And after that cos alpha by sin alpha gives us cot alpha, so here is 2, so you can write here 2 cot alpha, and 1 by 1, here is 1 also, so 1 by sin alpha equals to cosec alpha, which is our right hand side, and so we can write here proved. So left hand side here is under root 1 plus cos theta over 1 minus cos theta. So we have to see the right hand side. Right hand side there is a positive sign, so we are going to multiply here the numerator and the denominator with 1 plus cos theta. 1 plus cos theta here, because at the right hand side we have positive sign. If there is negative sign, if there be negative sign, so we would multiply up and down by 1 minus cos theta. Now the simplification gives us here at the numerator we can see 1 plus cos theta into 1 plus cos theta, so it becomes 1 plus cos theta whole square, and at the denominator 1 minus cos theta into 1 plus cos theta, that is a plus b into a minus b equals to a square minus b square, so we can write here 1 minus cos square theta. So we have to remove its under root sign because at the right hand side there is no under root sign. So at the numerator we have already got square. So we write as it is 1 plus cos theta its whole square. At the denominator we see 1 minus cos square theta. 1 square equals to 1 itself. So 1 minus cos square theta equals to sin square theta. And sin square theta, that is sin theta whole square. So we can write here 1 plus cos theta over sin theta and its whole square. Then you can remove under root sign as well as square. So we can write here 1 plus cos theta over sin theta. Now we are going to separate the base. That is 1 by sin theta plus cos theta over sin theta. And 1 by sin theta gives us cosec theta. And cos theta by sin theta gives us cot theta, which is our right hand side. Root. So we are going to choose left hand side here. Left hand side is 1 minus sin to the power 4 theta over cos to the power 4 theta. So at the numerator we can write 1 square minus sin square theta whole square. And at the denominator as it is, that is cos to the power 4 theta. And we apply a square minus b square formula at the numerator. So we write here 1 plus sin square theta, that is a plus b, and 1 minus sin square theta, that is a minus b. At the denominator we write cos to the power 4 theta. Now we see 1 minus sin square theta gives us cos square theta. So we write here 1 plus sin square theta as it is, and here we can write cos square theta. And cos to the power 4 theta, we can write it as cos square theta dot cos square theta. So 1 cos square we can cut up and down, and remaining we write here, that is 1 plus sin square theta over cos square theta. Now we are going to separate the base. 1 by cos square theta plus sin square theta over cos square theta. So 1 by cos square theta gives us sec square theta, and sin square by cos square gives us tan square theta. But we have tan square theta only at the right hand side, so we are going to change sec square theta into tan square, that is 1 plus tan square theta. And plus tan square theta, so here tan square theta plus tan square theta becomes 2 tan square theta. So finally we have 1 plus 2 tan square theta, which is at the right hand side, and proved. So we are going to choose left hand side. Left hand side equals to sec to the power 6 theta plus tan to the power 6 theta over, we write here sec square theta plus tan square theta. So we write sec to the power 6 theta as sec square theta whole cube plus tan square theta whole cube over, at the denominator as it is, nothing any change, sec square theta plus tan square theta as it is. So we apply a cube plus b cube formula at the numerator. So we write here a plus b, then a square means sec square theta whole square, a square, minus ab, minus a means sec square theta dot tan square theta, plus b square means we can write here tan square theta its whole square. And over, at the denominator we write here sec square theta plus tan square theta. So we know one formula. The formula is a cube plus b cube equals to a plus b, a square minus ab plus b square. That's the formula. So we apply here this formula. Now we see here the denominator and the numerator, sec square theta plus tan square theta, yes, we can cut, and remaining we have here sec square theta minus sec square theta dot tan square theta plus sec square theta whole square. So again we apply formula here, a square plus b square, right? So a square plus b square has two formulae, The second formula we apply. First formula is a plus b whole square minus 2ab. Another is a minus b whole square plus 2ab. So we apply here. A means sec square theta minus b means tan square theta its whole square, a minus b whole square plus 2ab. Plus 2ab means what now? 2 sec square theta dot tan square theta, and we have already here minus sec square theta dot tan square theta. Now we see here sec square. Now we can write the formula here. First of all, the formula is here a square plus b square equals to a plus b whole square minus 2ab, and another is a minus b whole square plus 2ab. So we write the second one. Why? Because sec square theta minus tan square theta equals to 1. So we apply the second one formula. Now the remaining we have here, we can see sec square theta minus tan square. This part gives us 1, so 1 is squared, and plus 2 sec square dot tan square minus sec square dot tan square equals to plus sec square theta dot tan square theta, right? Because 2x minus x is equal to minus x. So finally we have here 1 plus sec square theta dot tan square theta, which is our right hand side, and then proved. 28. So it's a very easy question. So we choose here left hand side. Left hand side equals to sine to the power 3 theta minus cos to the power 3 theta over sine theta minus cos theta. So we apply AQ minus BQ formula at the numerator. So we have here A, that is sine theta, B, that is cos theta, A minus B, then A square. A square means we can write here sine square theta A square plus AB. Plus A means we write here sine theta dot cos theta, and plus B square means cos square theta. Yes, we write. And at the denominator we have here sine theta minus cos theta. So one factor we can cut up and down, and remaining we have here sine square plus cos square. That's the so famous formula, sine square theta plus cos square theta equals to 1. So we write here 1 plus, right here sine theta dot cos theta, which is our right hand side. So it's a very easy but very important. So that is the right hand side and proved. So we can choose left hand side or right hand side, doesn't matter, both are equal. So let's choose left hand side. Left hand side is cos theta plus cos beta over sine theta minus sine beta. So we multiply up and down either by sine theta plus sine beta or cos beta minus cos theta. So we can multiply by any factor. So let's multiply up and down by sine theta plus sine beta. Here also sine theta plus sine beta. Now we are not going to do any change at the numerator, so that we can write here cos theta plus cos beta, and here also we have sine theta plus sine beta, and at the denominator we see sine theta minus sine beta, sine theta plus sine beta. That's we have in the form of a minus b, a plus b. So we write here a square minus b square, that is sine square theta minus sine square beta. Yes, we can write if a minus b plus b equals to a square minus b square. So numerator no any change, so we write cos theta plus cos beta, and another factor we have sine theta plus sine beta. Now we are going to change sine square into cos square because we have cos only at the right hand side at the denominator. So sine square theta gives us 1 minus cos square theta, and sine square beta gives us 1 minus cos square beta. So here is minus, we have to change the sign 1, and then we write here plus cos square beta. Now here plus 1 minus 1 will cancel, and remaining we write numerator as it is. So we have here cos theta plus cos beta, then we have here sine theta plus sine beta, and here at the denominator there is a minus cos square theta plus cos square beta. So write cos square beta at first, so we write here cos square beta positive at first minus cos square theta. Now we apply formula a square minus b square at the numerator as it is. So we have here cos theta plus cos beta, and here sin theta plus sin beta, and now here a square minus b square, so we apply formula a square minus b square as a plus b into a minus b. So we have cos beta plus cos theta, then we have cos beta minus cos theta. So we can cut up and down cos theta plus cos beta. We see here these two factors will cancel, because cos theta plus cos beta and cos beta plus cos theta same thing, x plus y plus x. So remaining we have here sin theta plus sin beta over cos beta minus cos theta. With that we have right hand side, it's proved. Hope you like the video. If you are new, not to forget to subscribe the channel, and please like and share also. Your feedback is precious for me. Thank you. Have a nice time.